Lesson 723, Division with Fractions and Decimals. We will work through a couple of these problems together, and then you'll have some work to do on your own when we're finished. So let's start with looking at problem 7-57. I'm going to read the problem out loud. You follow along with me, please. Donald and Ahmad were intrigued by homework problem 753 from our last lesson and decided to investigate other pairs of numbers that multiply together to get 1. Important information right there. Multiply together to get 1. They wrote the following number puzzles. We need to find the missing number in each of their puzzles and then show how we can find it using division. Let's take a look for a minute. Two numbers whose product is 1 are called multiplicative inverses, which are also known as reciprocals. All right. So when we're taking a look at this, my first job is to think about this problem, and I don't see any fractions here. So I'm going to go ahead and I'm going to think about the fact that over and over and over again throughout the school year, when we've talked about working with fractions and whole numbers, I often ask you or tell you that it's easier for me to think about doing that when my numbers both look like they're the same form. So this 6 that is a whole number here, I'm not changing the value, but I'm changing the way that it looks when I write it as a fraction like this. This makes it a whole lot easier for me to try to figure out what is missing, that I would multiply it together with 6 over 1 to get an answer that is equivalent to the number 1. Now, usually, I know that a number that is a fraction that has the same numerator and denominator, the same number in both of those, I can change that into the number 1. Since this is a number 6, I think to myself, if I'm trying to have a fraction that's equal to 1, and 6 is in the numerator position already, what would I need to multiply this number by so that I end up with a 6 in the denominator part? And I think for a moment, and then I'm like, oh, that's right. If I put 6 in the denominator, 1 times 6 is going to give me 6. Now I have to think what goes on top in the numerator position. 6 times what is going to give me 6? And look at that. My missing part of my equation is 1/6. 1/6 is the reciprocal of 6 over 1. And when I multiply these together, 6 times 1 is 6. 1 times 6 is 6. And I can do a little division problem, sometimes in my head, sometimes I just say it out loud. And I've got 6 divided by 6, and that takes me back to the 1 that was in my answer. Now let's take a look at this one. I do the same thing. I have a whole number 4, so I'm going to put that on top of a 1. And I'm multiplying it times something. And I want my answer to be finally the answer 1. And I'm going to switch it around a little bit so that my answer 1 is at the very end. Going back to what I was thinking about earlier, I know that 4 is in the numerator place here. And if I make a fraction that has the same number in the numerator and the denominator, I can do a math problem and end up changing that into a number 1. So 4 times what gives me 4? That's right, 4 times 1 gives me 4. And now I need to decide 1 times what is going to give me 4 over here. And that's right, 1 times 4 will end up equaling 4. And then that equals number 1 as my final answer, because 4 divided by 4 gives me 1. So both of these problems that I've already done, I have a 6 in the numerator and a 1 in the denominator, and then they flip or they change places, and we have a 1 in the numerator and a 6 in the denominator. So they both are reciprocals of each other. This problem here, we're not going to let it make us freak out or get too worried about it, even though 23 is one of the bigger numbers we've worked with in the past with our multiplication and division of fractions. I'm going to do the same thing where I change this into a fraction. It does not change the value, it just changes the way it looks. And now I'm going to think, what would I be missing in the middle here? I'm going to change this to the reciprocal. My 1 is going to move from my denominator into my numerator. My 23 is moving from the numerator, or the top position, to my denominator. And then when I multiply straight across, I have 23 divided by 23, which gives me 1 as my final answer. And as we read further ahead, Donald says, wow, we can just flip the fraction over to find its multiplicative inverse. Let's try some different examples. So this problem here, I'm going to start by rewriting this as a fraction that has the numbers written on top of each other. And if I flip this fraction over, it becomes 3 halves. And let's just double check that we did that right. 2 times 3 gives me 6. 3 times 2 gives me 6, and it equals 1. This one here I'm going to rewrite as 4 on top of 5. And I'm going to do some flipping around to get the multiplicative inverse, or its reciprocal. I'm going to move the 5 from the denominator location to the numerator. I'm going to take the 4 that's in the numerator position and move it into the denominator. Double check by doing my math, and I have 20 on top of 20, which when I do the math, I end up with a 1 also. This one here, again, I like to write them so they're on top of each other. To get the multiplicative inverse, to get the reciprocal, we just make a flip. 3 goes on the top or in the numerator location. 10 goes in the denominator. Go ahead and do the math, and we get 30 divided by 30, which also equals 1. All right, and then let's take a look at the next problem. The first one is pretty easy. If I want to flip this, I could make the 8 in the numerator, 7 in the denominator. I'm going to make my answer go left instead of right, which is fine. 8 times 7 is 56. 7 times 8 is 56, and that does equal 1. This problem, I'm going to move it up a little bit above. This is 1 5/10. We can write it like this. And then that can be changed by doing 10 times 1, which equals 10. And then we're going to add the 5, and that makes it 15. And then we're going to make sure everything stays on top of the denominator of 10. So my 15/10, if I switch that around, my multiplicative inverse becomes 10/15. Multiply it just straight across, and we get 150 150ths. Divide those numbers together with each other, and I get 1 again. So we have done that one correctly as well. And the last one, I'm going to move this one down so that we're using our space on our page as well as we can. This, if I read this decimal correctly, this decimal reads 25 hundredths. So I can write that as a fraction, change it right from my decimal. I'm going to use my multiplication symbol that kind of floats in the middle like a belly button. And the 25 that's in the numerator, to make my reciprocal, moves into the denominator place. My 100 goes from denominator to numerator. And I end up having 2,500 on top of 2,500. And that becomes 1 as well. Remember, you can pause, rewind, repeat any of the videos that I'm making for you for math class if I'm going too fast, or if you'd like to go back and see them again, because sometimes working through a video or working through a problem more than once is a way that you can catch on a little bit quicker. You might pick up on some things that you missed the first time through. The next thing that I want you to go ahead and do is 7-67. This is going to be your set of problems for your independent work. Down here, I would recommend that for these two problems, you rewrite them underneath, and I'm going to set you up letter E. We can rewrite as 2 71/100ths times 4 5/10ths. I like to set my multiplication up like this so that I can use the regular algorithm and make sure that I'm paying attention to how many decimal places I get. I would rewrite this one also to 35 hundredths, and I would multiply that times 0 and 1, 2, 3, 7 10,000ths. Go ahead and do that math. Be really careful about where you put your decimal points. And then I'm going to show you how we would go ahead and change this into a multiplication problem where the fractions both are improper or top-heavy fractions. So I'm going to do 3 times 2 gives me 6. 6 plus 1 gives me 7. And then I'm going to multiply, because that dot also means multiply the way this symbol does. Then I'm going to do 2 times 2 is 4. And then I take that number and add it to 1, and 4 plus 1 is 5. And now I can just go ahead and multiply straight across. You're going to do the same type of strategy for this one. Really important that you change these mixed numbers into improper or top-heavy fractions in order to be accurate and precise. All right, that's it for today. Hopefully Schoology will be working better for everybody.